Alright, so the idea for this tutorial is to show you how to have a rigid body simulation run on an object, and then partway through that simulation fracture that object into multiple pieces and have a secondary rigid body simulation cause it to look like it's fractured, like it's breaking apart. I've seen some tutorials of similar things, but usually they're just doing something simple like dropping a ball from a couple meters up or whatever onto a plane and having it break apart then, which can be done simply by dropping the fractured objects as well from the same height and just hiding them using the object that's still in one piece. The important thing here is that we're actually going to carry forward the momentum of the first simulation into the second simulation. I apologize if through any of this the cursor doesn't really sync up with what I'm saying exactly. I originally recorded all the audio for this while I was doing everything in Blender, but the audio track got corrupted, so I'm having to dub it over after the fact. Alright, so the only prep I've done here is modeling the ramp, and I've brought in an icosphere that I've subdivided a bit. So now we just need to set these things up to be a rigid body simulation. So just go to the ramp, make it rigid body, and make sure it's set to passive, otherwise it will be affected by gravity and everything. We want it stationary while the ball can interact with it. The other important setting here, because it has a concave area, is to set it so that it's using mesh for its collision box. The ball, meanwhile, we can just simplify and set it to sphere, because that's exactly what it is. And then if we hit play, it runs the simulation. I'm also going to want to add a plane in here to give the ball something to crash into after it has gone off the ramp. I did forget here that I've had a few issues with using a plane just because sometimes the fragments, if they're small, will actually glitch through a plane, so instead I'm going to extrude it out and use a box. That also just needs to be set up as a passive rigid body. And then once we have that in place, if we run the simulation, it'll interact with that as well. At this point, we have everything we need from this first simulation, so we're just going to bake it to keyframes because we're going to use the animation of those keyframes to carry over the momentum from the end of this simulation into the start of the next one. One of the easiest ways to find any kind of command or anything in Blender is actually to hit F3, which will bring up a search dialog, and then you can just type in bake to keyframes, and that'll show you the option. So you're going to want to select the sphere before doing this, and that'll make sure that the keyframes for the sphere get baked. What I've done here under the rigid body world options is just remove the rigid body world, which just deletes the rigid body property of all the objects. I'm not entirely sure this is necessary, but I have had some strange behavior in the past, so I've just done that and then set the ramp and the box up as rigid bodies again, as with the same settings that they had originally. The next step here is to actually fracture the sphere into multiple parts. I'm going to be using the cell fracture add-on, which is included by default in Blender, although I believe it's disabled by default. So if you just go into your settings for your add-ons and you search for cell fracture, you can enable it by checking the box. Then we can just use the F3 search dialog again to run the cell fracture on the sphere. I'm not going to go too much into the details here. There's some other tutorials online that go over a lot more information about the cell fracture add-on. I'm just using some settings that I've found work fairly well and keep things fairly simple for this one. One particular setting here you can set to make your life easier is to add a collection name near the bottom of the box, which will place all of the fragmented objects into a collection, which makes them easier to select and manage. Once cell fracture has worked its magic, you'll have a sphere that's been broken down into a bunch of smaller chunks. This is a good point to select all of the fragments, go into your object settings, set origins, and set them to be the center of mass based on volume. From what I can tell, center of mass matters quite a bit for rigid body simulations, so you ideally want it to be in the right place on these pieces. Next step is to select all the fragments and then control select the original sphere, and then Control P, you can parent the fragments to the original sphere. This means that the fragments will follow the ball through the entire animation that we have keyframed from the original simulation. We can't still have them parented to the original sphere, though, when we run the second rigid body simulation that's going to make them all fall apart. So what we need to do is use that search function with F3 again, look for bake action. In this dialog, you're going to want to turn on visual keying and then also clear parents, so that we don't have to clear the parenting relationship between all the fragments and the original sphere after this takes place. After we've done this, if you check, you'll notice that these fragments are no longer set as a parent if you look under their relations, and their animations are now fully keyframed to follow the original sphere. Next step is to find the frame where we want to transfer from the original simulation of the sphere to the one of it breaking apart. So I'm just looking for the frame where it's going to hit the ground. You're going to want to make sure you still have all of the fragments selected at this point, and then you're going to select and delete all of the keyframes after that point. Strictly speaking, this might not be necessary, but there's also no reason to keep these keyframes around at this point. Here I've just realized that I missed one keyframe, so I'm just going to get rid of that. Now there might be a different way to do this next part, but from what I can tell, there currently isn't in Blender, so I'm actually going to be making use of a couple of scripts. If you're intimidated by that, don't worry about it. They're actually very simple, and you don't need to write any code yourself. I'll have the text for them included in the description, and I'll go over a little more what they do later on in the video. So I'm just pulling up another little window here so I can open up a text editor where I can open up my scripts. Next thing we need to do is make sure that all of the fragments are rigid bodies. So you're going to want to make sure they're all selected. If you just click the rigid body button, then actually you're only applying that to the single active object, which is the one that's highlighted in a brighter shade of yellow. So after that, you're going to want to, with them all still selected, press F3 to bring up that search bar and search for copy from active, which is going to copy the rigid body off the selected active one onto the rest of them. By default, anytime you assign an object as a rigid body, it gives it a mass of 1 kilogram, but each of these pieces is a different size, so it would actually make more sense for them to each have their own mass based on that. There's actually a command for that, though, so you just bring up that search menu again, do calculate mass. You can pick whatever material you want here. I'm going to go for glass because that's what I'm going to make this sphere look like, and that will adjust the mass on them all. In this case, the masses are very high because it's a big sphere and glass is heavy, but the relative masses of them, I believe, is what should really matter. If you hit play on the simulation now, you'll notice that all that keyframe animating that we did is actually being completely ignored. That's just how rigid bodies work by default, so you need to tell them when they're being animated by keyframes and when you want the simulation to actually take over. That's where the little checkbox here for animated in the rigid body comes in. An important thing to note is that with all of the objects selected, if you just click the button and check that box, it'll actually only turn it on for the activated one when what we actually want is for them all to be affected. To do that, hold down your Alt key, then click the box, and it'll toggle that property for all of the selected objects. The thing is, we also want to keyframe that being on one frame and then off on the next when we're switching from animated to simulated. Problem is, in Blender, at least as far as I can tell, there's no super simple way to do that. You can't just mouse over the keyframe button here and hold Alt and click it to assign keyframes for it all. That's where the scripts come in. So this script is pretty simple. All it does is it goes through the list of all of the currently selected objects, and it creates keyframes for both the dynamic and animated checkboxes. Dynamic I don't think we actually need to deal with in this case, but I just created the script this way because I was working on something else when I used it last. So you're going to want to go to the frame where the last keyframe is that we brought over from the original animation. Up until this point, we want the rigid bodies to actually be controlled by those animated keyframes. So you're going to want animated on, and then if you just click the run button on the script, it'll add those keyframes for all of the selected objects. Then you're going to want to move to the next frame, holding Alt again, click the animated box so that it turns off on all the objects, then run the script again to add keyframes for that. This means that starting on this frame, we are not going to be using animation anymore. We're going to let the simulation take over. The reason for doing all this is that if you just had the fragmented ball at this frame and it wasn't in motion previously, and then you start the animation, it's just going to drop to the ground and crumble. It's not going to scatter like a ball would if it shattered as it hit the ground while moving. Or in other words, we're relying on those keyframes to provide momentum going into the simulation. At this point, we're actually pretty much done. If you hit play, it'll roll down the ramp and shatter all over the ground. There are just a couple more steps before we can get to actually rendering this, because right now both the original ball and the shattered pieces are visible at all times. In the render at least. Right now I've got the original ball turned off just so I can see what I'm doing. What we want to do at this point is on the frame where we're going from the original simulation of the ball and then switching to the fragmented pieces shattering on the ground, we want the original ball to stop rendering and for the other pieces to start rendering. I'm going to start by setting this up on the fragmented pieces. So I'm going to select them all and then Alt-click the render visibility in the outliner. If that doesn't show up for you, just click the little funnel icon near the top right of the outliner window and it'll let you turn on which visibility options show up for you. Again, it's important here to be holding Alt when you click it because that'll toggle that option for all of your selected objects. Of course, we also need to animate this. The easiest way I've found to add keyframes for that setting is another script. It's another simple one. It just walks through the list of all the selected objects and keyframes that specific property. So you just hit run on the script and it'll add those keyframes. Then just like we did earlier, you just want to go to the next frame, hold Alt, turn visibility on, and set another keyframe by running the script. Then we just have to do the same thing for the original ball, except set it up so that it is originally visible and then disappears on the frame where the fragments appear. In this case, we don't need the script though because it's just one object, so just toggle the visibility by clicking on it and then press I to set the keyframe for that frame. You'll still be able to see both objects all the time in your viewport, but when you render, they'll be visible when they're supposed to be. One last thing I like to do here is go into the scene settings under the rigid body world, go into the cache, and just bake. That'll essentially lock the simulation in so that it's not trying to recalculate it as you're scrubbing back and forth through frames. Then I just slap some materials on, switch over to cycles because I just prefer to render in it personally. I just like the look. Just a quick note here about scripts because I realized I didn't really explain how to set them up or anything during the video. When you open a regular default file, there should be a scripting tab at the top. If you go to that, the largest window in there is the text editor, and in there you can just click New, enter the text of the script you want to run, change the file name to whatever you want, and then just click text and save it somewhere convenient for you. Then anytime you want to run that script, you just have to click the little play button and it'll activate. And finally, after rendering, this is what we end up with. Hopefully this has been helpful for some people. If you have any problems or questions, feel free to post a comment below and I will get to them as soon as I can. Thanks for watching and have fun breaking things.